On page 33, we're looking at solving systems using the table function in the calculator. Not usually my favorite way to solve systems, but basically, if you're going to use the table function, which is used by, I don't know if I can, okay, let me just type it in here. Y equals 5x plus 1. Y equals 5x plus 1. There's the first one. And I can make this a table if I hit that. It's what the hell is that thing? A gear wheel right there. Okay. And then the first icon after this is a table. And the table has some automatically put in there things. And we're just going to leave that right where it is. And then we're going to go ahead and put the next one down here, which is y equals 2x plus 1. And we're just going to see if we can find a situation where a certain input yields the same output. So there's that, and I'm going to hit here, and I'm going to hit here. Nope, I'm going to hit here. And I'm just looking on here. I have to like zoom in a bit to see that 1, 3, 5, 0 will make a 1 at the top, and 0 will make a 1 underneath. So our solution must be 0, 1, but it's really hard to use a table function when you can just go ahead and tap on where you see those intersect. So the solution for this one is going to be 0, 1. Let me just get my pen on here and I'll write it up on the notes. So that's pretty much the straightforward thing with calculators. If you want to do that next one, I'm just going to let you pause and then you can come back and see if you got the right answer. If you use the table function or the graphing part of the calculator for the second example, your answer should be 3, 3. So I'm going to go ahead and take this away, and I am going to bring us to the next page. I also want you to just take a quick notice at the bottom of this because WebAssign is going to say something to you about whether a solution is consistent, inconsistent, dependent, or independent. So I made a little table at the bottom here. If you have one solution, that means that it's consistent and independent. If you have infinitely many, that's consistent and dependent. And if there's no solution, we call that inconsistent. And there's a little bit of a description here on the side of what those things mean. But for the most part, you just need to be able to get through the homework. So that's, not something we need to spend a lot of time on. Looking at page 34. Use substitution. This is a different method to solve systems. So substitution basically happens when you have two things that are equal to something. That means they're equal to each other. For instance, right here, this is that y is equal to x minus 3 and y is equal to 2x minus 4. I could say, well, y is equal to y, and I can substitute x minus 3 because this says this, and I can substitute 2x minus 4 because this says this, and I can solve for x. So if I just get x's on one side and my constant on the other, I have x equals 1. That's part of the solution. In order to find the y, I can just use one of my first two equations and substitute 1 in for x. Y is going to be -2. If you are not confident or you want to do a thing where you're checking, you can go ahead and you can, on the side here, graph these. This is the first one, y equals 1x minus 3, and then -4, rise 2. There it is right there. That's the solution because that is a point that they both share. So the solution, 1, -2. So I'm going to go ahead and give you a moment to do questions number 2 and 3, even though actually I don't even know what these are, number 2 and 1. I don't know. 2 and 2? I don't know. You're going to pause, do these next two examples, and then you can come back and get answers for them. There's the answer to the first example. The second one, notice that this has just a value that's equal to y. So in that second equation, I'm going to plug -5 in wherever I see y and solve for x. So x must be 0 and y is -5. According to this, y is -5, x is 0. Not too bad, hopefully. Okay, we have 3 more examples. You're going to do all 3 of these in your notes and come back and check your answers with me. Okay, I noticed that I have the same question twice. That's so great. Here we are. There's the answers to those first two, and that's not too bad. Pause if you need to look at it more.